All right, well, welcome everyone. I am JJ. Let's tackle an example problem. So we have a beam is loaded with our force system shown in here. Let's determine a resultant couple moment on that. So I have three couples on here, F1 equal and opposite, F2 over here equal and opposite, F3 equal and opposite. I can sum all of those up and get to a single resultant couple moment on this. Really, it's the same process we do for if we just had one couple acting on something. We just want to say, let's come in and take a positive direction. With positive going counterclockwise, we're summing up our couples. Summing up our couple moments here. So let's deal with F1. It's at an angle, so I'm going to split this into X and Y components for everything. So let's get the Y component in there first. We'll check its rotation direction. So on the left, it points down. On the right, it's pointing up. If I pull my paper in that direction, pull down on the left, push up on the right, it's going to spin counterclockwise. So put that in here as positive. My force is the Y component, F1, or 750, times our cosine of, not cosine, this measures from horizontal, times our sine of 60, sine 60, times an X distance from between the two Y components of F1. From here to here, 12 inches, times 12. Then we can get our X components. On the bottom, it's going to the left. On the top, it's going to the right. If I pull to the left on the bottom, the right on the top, my paper would start to spin clockwise if I was doing this on paper. So we've got to be able to picture that out. Try physically doing that if you're struggling with moment directions. Figure out how to spin a piece of paper, work through that. We have examples that kind of talk through that in earlier videos. But that means we need to subtract this one out. It is going clockwise. So minus the X component in here would be 750 cosine 60 fx. So I need a Y distance for everything. My Y distance from my two components is 10 inches. So times 10. Then we can go to F2. F2, if I pull to the right up on top, the left down below, I should get a clockwise rotation. So minus, my force is 800. And I'll need to multiply by, that's an X force, a Y distance, 12 inches, times 12. And then finally, I can come in and go back to F3. F3 on the left goes up, on the right goes down. That's also clockwise. So minus, my force is 500, times my distance between my two components is 12 inches. Minus 500 times 12. Or that's going to get us that this is equal to negative 11,500 pound inches going counterclockwise. Negative counterclockwise is the same thing as a positive clockwise. Let's always report our moment, any moment related thing, as a positive with the correct rotation direction on it. So this is really that our sum of our couple moments is 11,500 pound inches, and we drop that negative, so we need to change our direction here, going clockwise with that. And that would be our answer in there. One other thing we might do, especially if I'm getting a really large number out here, if I had to use this again, I might consider converting that to pound feet. We get like 962.5. It's a little bit easier to not make a calculator mistake with a smaller number there. There's no reason we have to do that. Pound inches is also completely acceptable. But hopefully this was useful for you. If it was, hit the like and subscribe button. Let's get you an A with JJ.